In this lesson, we will solve linear systems of equations in two variables by the elimination method, also known as the addition method. So far in this chapter, we've solved systems of equations. We started out by solving it algebraically, where you plug in a point to see whether it is or is not a solution. And then we also did the graphing method, solve by graphing, where you graph the two lines, see where they touch. If they touch, then there's a solution at the intersection point. And we also covered in the previous section solving by substitution, and that method is where you are going to plug one equation into the other to find your solutions. And now this brings us to the elimination method, also known as the addition method, for solving equations. You can also use this method. It is generally the easiest to use. Students find it easy rather than some of the others. And the equations are usually in standard form. So there's are the instructions listed. I'm not going to read through them, but I'll take a moment and let you silently read through it, and then we'll get started. Okay, so let's get started, because it's much easier than reading the instructions. For me to just walk you through it, you'll understand it a lot better. And then when you read the instructions again, it'll make more sense to you. But step one with the elimination method is to make sure that both equations are in standard form. And recall standard form is where x is first, then y, and then the constant number is on the other side of the equation. And notice in both cases of these equations, they are in standard form. So now we can go ahead and proceed. The next step is to look for a variable term that has a coefficient of 1 or -1, just like we were looking for that with the substitution method, but we're going to do something different with it this time. So notice in equation number 1 is the x that has a coefficient of 1. For equation number 2 is the y that has a coefficient of 1. So either one of those you can choose to eliminate. And that's why they call this the elimination method, because you have to eliminate one of your variables. In other words, notice when you solve substitution method, you had to solve an equation. Once you plugged it into the other, you actually had to solve the equation for x or solve it for y. Well, the thing with equations is you cannot solve for x and solve for y at the same time. You can only solve for one variable at a time. So that means you have to eliminate one so you can solve for the other. So in this particular case, I'm going to choose to eliminate my x's. And again, I made that conclusion or that decision because I notice here that the x had a coefficient of 1, so it will be easiest to eliminate my x's here on this side. But I have to do something to the x in the first equation. So you think about, okay, you have these terms, x and 3x, and you want to add them together so that they equal to 0, they zero out. So the only way that's going to happen is with the first equation, I would have to multiply that by not only 3 so that it's the same as that, but -3 so that it becomes the opposite of the term that's underneath it. And that's the other thing I forgot to mention, is that when we're using this method, you must always line up your terms in order, x, then y, and then the number by themselves. That's the reason why you put it in standard form, is because recall, when adding polynomials, you can only add polynomials that are like terms. So that's why you line them up with their like terms. So to eliminate our x's, all I need to do again is to multiply the top equation there by -3. When I do that, So notice here on the bottom, we're going to multiply by 3 because I can't just do it to just the x alone. You know, with equations, the rule is what you do to one, you have to do to everyone. So I have to multiply everyone in that whole top row of that first equation by -3. So it'll be -3 times x, and then -3 times -4y, -3 times -4. So when I do that, I'm going to rewrite that equation. And again, we're not doing anything to equation number 2, only to equation number 1. And the reason we did that, you can see here now, if we take a look at my x's, they are opposites of each other. And so I have accomplished my mission of eliminating my x's. Because now 3x minus 3x, a positive 3x and a negative 3x, they cancel each other out and they are gone. And that's basically what you wanted to happen. So I'm going to, on the next sheet of paper, we're going to move over and we're going to make it bigger so that you can see, but I just wanted to go over that whole process of first determining which variable you were going to manipulate. And here we decided on the x's to eliminate our x's, which means I had to subtract the top equation by -3. So now that we've rewritten that equation there, we're now ready for the step of adding, and that's why they call this the elimination, also known as the addition method, is because once you rewrite that equation, then it's time to add the two equations together. So let's go ahead and do that. We're going to add the two equations together, and as we stated before, our x's have canceled out, they're gone. But for our y's, they're still there, 12y plus 1y. We know that in algebra you don't have a 1 there, but we know that a 1 is assumed when it doesn't have a number out in front of the variable. So that's going to leave us with 13y on the left side of the equation, and on the right side, when we add the constants, we're also going to get a 13. So 13y equals 13. Last step to solving this equation is to divide by 13, and y equals 1. So we have an output for our solution of y is 1. So how do we find x? To find x, all you have to do is plug it into either of the two original equations in y's place, one or the other. You do not need to plug it into both. So I'm going to go ahead and plug it into the first equation, remove y, and replace it with 1. When we do that, we're going to have -4 times 1, which is going to give me -4 there on the left side. Last step to solving this equation is to add 4 to each side, and x equals 0. For those of you who decide to plug it into the second equation, that's fine as well. You'll get the same answer. So into that equation, if we remove the y and replace it with 1, it's going to look like so. Our next step to solving this equation is to subtract 1 from each side, then divide by 3, and x again is 0. So it does not matter which one you plug it in. You don't need to plug it into both equations. It's one or the other will give you your other variable. So my solution here is 0, 1, because I got a 0 for x and I have a 1 for y, which gives me an order pair solution of 0, 1. Okay, so the last step is step 6, and this step really is optional. If you're sure about your math, then you don't have to do this step. It's just an extra step you can do to make sure that your answer is correct. And all you have to do is just plug your solution back into either one of the equations, one or the other. You don't need to do both. And if it leaves you with a true statement, meaning both sides are the same, then that's proof that that's the solution. So our solution, recall, was 0, 1. So we're going to plug that in, 0 for x and a 1 for y, and do the math. When we do so, it does check out for the first equation. So that is your proof there that yes, 0, 1 is a solution to this system of equation. Now, for those of you who may have been following along, but you plugged it into the second equation, that's fine too. Let's go ahead and do that one, and we'll show you that you'll still get the same answer. So into the second equation, plugging in a 0 for x and a 1 for y is going to look like so. And again, we can see here that it does check out. And so our solution indeed is 0, 1.